Welcome to Mission Control. This is your flight director speaking. And today you are tuned into a highly specialized explainer of the ultimate examiner's playbook. We're running a full-scale flight simulation for Cambridge Mathematics 9709, specifically targeting the AS and A-level airspace. Look at the central console screen. Right there, that is our primary objective for today's mission, mastering the inverse relationship between logarithmic and exponential functions, specifically e to the power of x and the natural log of x. Now, this isn't a standard textbook reading. We are treating your exam paper exactly like a complex flight system that demands absolute perfect execution. To help us demonstrate, I want to introduce you to our two simulation pilots for today. First, we have pilot Alex. Alex is brilliant but constantly overcomplicates data calculations, burning way too much time and mental fuel trying to brute force the math. On the other side of the cockpit, we have pilot Sam. Sam is fast but consistently ignores structural boundary constraints, skipping steps and risking a total systemic breakdown of the mathematical proofs. We are going to track both of them today, analyze their telemetry, and show you exactly how to navigate this airspace like an elite systems engineer.
So, why are we prioritizing this specific trajectory? Look at this payload right here, 15%. That is a massive number. According to our pre-launch telemetry and syllabus analysis, this precise topic accounts for approximately 15% of your total marks in Paper 2. We are talking about a completely high-stakes opportunity here. This isn't just some minor turbulence you can ignore. This is the main engine of your exam score. If you can lock down the precise mechanics of how e to the x and ln x interact, you are successfully securing a massive chunk of your final grade. Our mission today is to make sure you don't leave a single one of those marks on the table.
All right, let's quickly run through our pre-flight checklist. We've got 5 waypoints. 1, the 15% opportunity. 2, core concepts and theory. 3, the method mark strategy. 4, procedural framework. And finally, waypoint 5, top examiner warnings. Let's initiate the launch sequence.
Waypoint 2, core concepts and theoretical architecture. We are building the foundation of this spacecraft right now.
Okay, we are actively monitoring the approach trajectory now. On your high-tech UI console overlay, you'll see the core assessment objectives for Paper 2. We are treating these command keywords as strict system parameters: knowledge, application, analysis. Now, watch pilot Alex for a second. Alex is trying to rote learn every single possible equation variation, completely burning out the engine. Meanwhile, Sam is just plugging numbers into the calculator without proving the logic, flying right past the analysis requirement. Both are going to lose marks. Cambridge examiners are prioritizing depth over superficial breadth. You have to understand the theoretical architecture here. It rests incredibly heavily on precise definitions. You need to show exactly why the natural log undoes the exponential function. It's all about logical reasoning. If your analysis doesn't demonstrate that causal relationship clearly, your system's going to crash on impact.
Look at this telemetry data coming directly from the principal examiner reports. Candidates referencing cross-topic connections achieve significantly higher marks. This is exactly how we clear orbit. Treating e to the x and ln x in total isolation is a fatal error. When the exam throws a complex trigonometric equation at you that suddenly simplifies into a natural log, or asks you to integrate an exponential function nested inside a calculus problem, that is the examiner testing the integrity of your entire flight system. You have to integrate these functions with other syllabus areas. Connect the dots. That is the maneuver that separates the standard pilots from the elite candidates.
Waypoint 3, the method mark strategy. This is where we secure your points for process.
Before we analyze this exact roadblock, flight director overriding the console here, I am pausing the simulation for a mandatory mid-flight check. Before we fire the secondary boosters to secure those maximum method marks, you need to optimize your flight path. Hit pause, subscribe to AC Exams at the handle at AC Exams right now, and turn on all your notifications so you never miss a critical mission update. Okay, boosters engaged, simulation resuming. So, look at the main screen. Why do students find multi-stage analysis and method marks so difficult? This is the exact anomaly that stumps candidates. They see a massive 5-mark algebraic monster and they just freeze.
And right on cue, we are seeing our crew encounter a critical roadblock mid-paragraph. Both Alex and Sam are staring at a massive multi-stage equation, and their evidence links are completely failing. They are losing altitude fast. Flight director overriding the console again. I am injecting the PEL structural template right into their nav computers to save this trajectory. Point: evidence, explain, link. We combine this with our deconstruct, solve, and evaluate sequence. Step 1, identify the given information. That's your point. Step 2, break it into logical steps, isolating variables. Step 3, solve systematically. That is your evidence and explanation. Step 4, check for reasonableness. You can't have a negative value inside a natural log. That breaks the laws of physics in this universe. And step 5, make justified recommendations. That's your link back to the original question. If you follow this stabilized flight path, you capture every single possible method mark along the way.
This entire maneuver is officially classified as systematic processing. It is a standardized sequence. The examiners are basically reviewing your flight recorder data. They want to see that you can identify key elements, apply principles, and execute your analysis with undeniably clear working out. It's about verifying your results and presenting them flawlessly. This is the exact definition of the professional standard required to pass Cambridge inspection.
To guarantee you execute this perfectly under G-force pressure, I'm uploading a memory hack into your system, ESEP. Extract the data. Select your framework. Execute precise notation. Seriously, watch your brackets. A missing bracket is a compromised hull. And present with correct terminology, ESEP. Write that acronym down on the very first page of your exam paper the moment you sit down. It acts as an automatic pilot stabilizing your presentation conventions.
Waypoint 4. Evaluation and Examiner Insights. Time to navigate through the asteroid field.
All right, team, listen up. We are initiating a live interactive viewer radar challenge right now. I am putting a highly complex source block on the main screen. I want you to imagine a 60-second visual countdown clock ticking away right there in the corner. Your mission? Locate the hidden core variable in this comparison. Simulation 1 is a go. The challenge is spotting the difference between generic mathematical answers versus context-specific evaluative answers. Time's up. Did you spot it? The core variable is context. The ultimate trap is doing the perfect math, finding x equals 4.2, and just stopping. If the question is about an exponential decay of a chemical compound, x equals 4.2 means absolutely nothing to the examiner. You have to explicitly state the compound reaches its half-life at 4.2 hours. Context is your heat shield. Do not re-enter the atmosphere without it.
Moving straight into Simulation 2, debris detection. I am pulling up mapped examiner warnings. Look at this table. Your radar challenge here is to identify the specific sentence where a sample student answer falls below compliance standards. Look for the debris. Mistake 1, wrong approach for the context. Action to fix, extract specific data. Mistake 2, forgetting format. Action, check strict mathematical conventions. Mistake 3, vague, non-specific answers. Action, link it back to the context. If you see your own working out starting to drift into any of these mistake categories, you need to recognize that debris on your radar instantly and take immediate evasive action. To fully clear the debris field, you need to engage your comparative analysis elements. When the flight manual asks you to evaluate two different mathematical models, don't just list numbers. Identify similarities and differences. Use comparative connectives like conversely or in contrast. Support every single claim with hard mathematical evidence from your working out. Draw firm conclusions about relative importance. You are using the inverse relationship of these functions to actively question the underlying assumptions of the problem itself. That is elite-level flying. Final waypoint, mastering the playbook, initiating the final review checklist.
Telemetry looks good. Alex and Sam are both aligning with the proper trajectory. I can confirm a successful full-mark touchdown sequence is locked in. Let's distill this entire simulation into your mandatory pre-flight question scan checklist. 1. Secure that massive 15% payload by hunting down every single method mark. Show all your working. 2. Apply the ESEP framework on every multi-stage question. Extract, select, execute, present. And 3. Completely avoid generic floating numbers by always linking your final answers directly to the real-world context of the problem.
As we power down the main console, I want to leave you with one final, critical diagnostic question. If e to the power of x and the natural log of x are pure, absolute inverses of one another, how exactly will you leverage that unique relationship to tear apart and evaluate the underlying assumptions in your next past paper? Think about that before your next practice run. This concludes our Flight Simulation Explainer. Do not forget your final protocol. Hit that subscribe button for Ace the Exams at the handle at Ace the Exams, enable the notification bell so you never miss a briefing, and drop a comment below right now sharing your specific subject and tier. Let me know what you're flying next. Mission accomplished, team. Dismissed.